Have you ever looked at a hybrid car and just wondered, what's really going on under there? I mean, you see a Prius, you see a Civic hybrid, they kind of look the same from the outside, right? But believe me, the way they work, their whole engineering philosophy is totally different. So today, we are going to pull back the curtain and demystify the three main types of hybrid systems. Let's jump in.
All right, so here's the game plan. First, we're going to tackle a really common myth about hybrids. Then, we'll dive into the three main designs: the series, the parallel, and the super clever combined hybrid that, kind of mixes them together. And to wrap it all up, we'll finish with a simple cheat sheet so you can remember everything.
So, first up, the hybrid question. Before we get into all the different types, let's set the record straight on a key idea that a lot of people get mixed up.
So, do you think all hybrid cars work the same way? It's a pretty common assumption. A hybrid has a gas engine, it has an electric motor, and they work together. Seems simple, right? Well, it's not quite that easy. How they work together, and sometimes how they specifically don't work together, that's where the real magic happens.
Okay, so let's get on the same page with a basic definition. A hybrid electric vehicle, or HEV, is just any car that uses two different power sources to get you moving: an internal combustion engine, that's your standard gas engine, and an electric motor. The big difference isn't what they use, it's all about how those two things connect to the wheels.
So let's meet our first contender, the series hybrid. Now for this one, I want you to try and forget everything you think you know about a gas engine driving a car. Instead, just picture it as your own personal power plant that just happens to live under the hood.
You see, the power flow here is totally indirect. The gas engine's only job is to turn a generator, which makes electricity. Now, that electricity can do one of two things. It can charge up the battery, or it can go straight to the electric motor. But here's the crucial part. It is the electric motor, and only the electric motor, that physically turns the wheels. This is an absolutely brilliant setup for city driving, because the engine can just hum along at its most efficient speed, making juice no matter if you're speeding up or stuck in stop-and-go traffic.
So if you remember one thing about a series hybrid, make it this. The gas engine has absolutely no mechanical connection to the wheels. None. You're basically driving an electric car that's carrying its own little generator around.
All right, on to type number 2, the parallel hybrid. And really, the name kind of gives it away. Here, you've got two power sources, the engine and the motor, running side by side or in parallel, and both of them can connect to the wheels.
This system is all about having options. So, say you're cruising on the highway at a steady speed. Well, the gas engine can just take over directly, because that's what it's most efficient at. Just bopping around town, the electric motor can handle that all by itself. But what if you need to merge onto that busy freeway? The car can call on both the engine and the motor to work together for a big burst of power.
And that is a fundamental difference. In a parallel system, either the engine or the motor or both of them working together can send power straight to the wheels. It's a real team effort.
A classic real-world example of this is the Honda Civic Hybrid. It's really designed to let that gas engine do most of the work on the highway, with the electric motor jumping in to help out when it's needed.
Okay, so let's just pause for a second and compare. The series hybrid, it's basically an electric car at heart, so it's amazing in city traffic. The parallel hybrid, with that direct engine hookup, it just shines on the highway. Each one has its own special talent, which of course leads to the big question: can you have both?
And the answer is a big resounding yes. Which brings us to our third and final type, the combined hybrid. You might also hear it called a series parallel hybrid, and that name says it all. This is the sophisticated system that tries to give you the best of both worlds.
So how does it pull this off? Well, at low speeds, it acts just like a series hybrid, running quietly and super efficiently on nothing but the electric motor. But once you get up to highway speeds, the car's computer is smart enough to engage the gas engine to power the wheels directly, just like a parallel hybrid. The car's brain is just constantly figuring out the most efficient way to run second by second.
And that's really the magic of the combined hybrid. It's this super intelligent system that gives you the amazing city efficiency of a series and the powerful highway cruising of a parallel, all rolled into one car.
And the most famous example of this complex, super efficient system, I bet you guessed it. It's the car that made hybrids a household name, the Toyota Prius. It is the absolute textbook example of a combined series parallel hybrid. Whew! Okay, we have covered a lot of ground. So let's bring it all home and put everything together in one simple spot. This is your hybrid cheat sheet.
This table really makes it all crystal clear, doesn't it? Just look at that first row. Engine to wheel connection. For series, it's a big no. For parallel and combined, it's a yes. That's the main dividing line right there. And then you look at the advantages. Series is the king of the city. Parallel owns the highway.
And the combined hybrid just, well, it masters everything. And of course, you've got the real-world examples right there to help it all stick. So, after breaking down all these incredibly clever ways to power a car, it leaves us with one last really interesting question to think about. As the world keeps moving more and more towards fully electric cars, what does the future hold for these hybrids? Are they just a stepping stone on the way to full EV, or will they always have a place of their own? Something to chew on. Thanks for joining me.